you want to maybe go into a little bit of detail about what those, like maybe a couple handful of problems that we've solved over time that will work well in this for this application?
Yeah, sure. The traditional ways of doing implementing this SoC core power is that there is a controller. There are discrete components like a couple of FETs, and then for current sensing, there is a DCR way of doing the current sense, and then the temperature sensing, and all of this is done in a very discrete way. So it takes a lot of components, and then it takes a lot of effort from the designer to design with so many components. But and also another thing is that the controller was an analog controller. So where if you have any changes to make, then the designer has to go change the components, redesign everything, or optimize it. But the MPS, how we approached it was, we made digital controllers. So these have MTPs, so where you can read and write them multiple times. So these are digital controllers, and they are multi-phase. So that's on the controller side. And then for the power stage, instead of using high side FET, low side FET, external current sensing, and all of that, so we came up with the monolithic driver MOS technology. So everything is integrated. In that power stage, you get both the FETs on there, and then the current sensing and temperature sensing is all done, and then all kinds of protection features all implemented on a single piece of silicon. So from design standpoint, it is very easy to design them, very easy to scale up or down, and it speeds up the design cycles, very flexible, very scalable solutions, and very efficient as well. So since these are monolithic driver MOS, everything is on a single piece of silicon, so we can really optimize them and get the highest efficiency and fast transient response as well.
Yeah, so that's the benefit of having 5 generations of this product, where you're integrating all of those into, you keep finding different things that you can pull in, different functions, right?
Exactly.